This equation of methane and oxygen reacting to create carbon dioxide and water is unbalanced and a skeleton equation. What this means is that if we counted the number of carbons, hydrogens, and oxygens on the reactant side and the product side, we wouldn't have the same number of atoms. In the actual chemical reaction, there are 2 molecules of oxygen, and the reaction rearranges them into 2 molecules of water and a molecule of carbon dioxide. So, to balance the equation, we have to add coefficients. These are whole numbers placed in front of formulas to balance the equation. In this case, there needs to be a 2 in front of the oxygen and a 2 in front of the water. Then, we can count the number of atoms on each side of the equation. And they're the same. Matter is conserved. Huzzah! When we balance equations, our goal is to conserve mass, because during a chemical or physical change, matter is neither created nor destroyed. That's why we need the same number of atoms on the reactant side as the product side. The main ideas for writing a balanced equation are to first write a skeleton equation, and then add coefficients until it's balanced. But if that's too vague, here's a more delineated process. First, write the formulas of each reactant and product. Add the arrows, plus signs, and other descriptors like solid or aqueous. Write the number of atoms on each side of the equation, but keep the polyatomic ions as a single unit on each side. Balance with coefficients, and check each atom as you go to see what the current count is, and use lowest possible ratios of coefficients. Let's try an example. Hydrogen gas and oxygen gas react to produce liquid water. First, let's write down the formulas of the reactants and products. Hydrogen and oxygen gas are both Brinkelhoff twins, so we need to write them down as diatomic. Water is H2O. The phrase react to produce is where the arrow goes, and anytime you see the word and, use a plus sign. Now we can add other descriptors, gas for hydrogen and oxygen, and liquid for water. Next, you write out the atoms on both sides and count how many of each are on both sides. At this point, you can see that oxygen is not equal on both sides, so we'll add a coefficient in front of water to attempt to fix this. A 2 will mean that there are 2 entire water molecules, so now that means there are 2 oxygens and also 4 hydrogens. That 2 coefficient will multiply with the 2 subscript next to the hydrogen. So let's go back to the reactant side and put a coefficient of 2 in front of the hydrogen, which makes 4 hydrogens, and now it's balanced. Thanks for watching this episode of Teacher's Pet. Don't forget to like and subscribe, and follow me on Twitter @SciencePet.